Hi everyone, good morning.
Eurasian landmass, eastern part of Pacific Ocean, You draw these Americas, North America and South America, Pacific Ocean one here. Then, excellent. Let's start with it, and the question, the basic concept remains exactly same. North equatorial current in Pacific Ocean, south equatorial current to the south of equator. Why do they flow north and south? We know that trade winds play a role. Parting of water takes place because these islands obstruct. Water level is higher, temperature is higher, expansion takes place. So this causes ocean currents to flow northwards. This causes ocean currents to flow towards poles. Right? Name of the current is Kuroshio current. At Kuroshio current. Then, as it is moving northwards, Kuroshio current, obviously westerlies will show its effect, and because of that westerly effect, currents will flow from west to east, called as North Pacific Drift or North Pacific Current. North Pacific Drift or North Pacific Current. Done with this? Now, western part thing, some of the cold currents will flow because of melting. So there's a very strong cold current called as Oyashio. Oyashio का एक part current है जो Kuril current के Kuril Islands के पास में known as Kuril current. Kuril Kuril current. Kuril current. Then to the further west of that there is a coast current OKL. OKHOSTOK, or coast current. All three are cold currents. हालांकि ओयाशो ही है जो bifurcate होता है. ओयाशो is the main current. And we know the reason why they are flowing. We should also know the effect of these ocean currents. Fishing grounds कहाँ बनेगा? Now this North Pacific drift under the impact of westerlies reaches to the coast of Alaska. Here it is known as Alaskan current. Alaskan current. Gulf of Alaska to the coast. There is a coast current, OKHOSTOK, or coast current. All three are cold currents. हालांकि ओयाशो ही है जो bifurcate होता है. ओयाशो is the main current. And we know the reason why they are flowing. We should also know the effect of these ocean currents. Fishing grounds कहाँ बनेगा? Now this North Pacific drift under the impact of westerlies reaches to the coast of Alaska. Here it is known as Alaskan current. Alaskan current. Gulf of Alaska. It forms some kind of rotation there because of the effect of coastline. Then again that wind pumping may separate the ocean current called as California current. California current will merge in this upwelling of water towards east. And because of that desiccation, done with this? कोई confusion इस पे? Why are they blowing? Regions कहाँ पर होगा? क्या effect होगा? Names are very very simple. कुछ भी changes नहीं है मतलब process में. हाँ, थोड़े नाम add जरूर होंगे. Kuroshio current, like along the coast of Japan. फिर वहां से cold currents जो आ रही है, तो नाम थोड़ा अलग है. Okhotsk current है, Kuril current है, Oyasho current है. एक और current मिलेगा आपको यहाँ पर Tsushima current in the northern part of Japan. But process is going to remain exactly same as we had mentioned there. And we know that ocean bottom topography of Pacific Ocean is simpler than Atlantic Ocean. क्योंकि ocean bottom topography is too deep. Sea mounts भी परेशान नहीं करेंगे इनको. मतलब जो ocean bottom topography है, it is not going to have much influence on these ocean currents in Pacific Ocean because that's much deeper. ये परेशान कहाँ पर होगा? दो जगह हो सकता है, या तो Indian Ocean में हो सकता है या फिर Atlantic Ridge में. But you see, Indian Ocean Ridge is much deeper than Atlantic Ocean Ridge. That's why you see so many names, so much of division of ocean currents. यहाँ पर इतना effect नहीं रहेगा. In southern hemisphere, the process remains same. This current is flowing southwestward, or it is moving towards south. Why does it move towards south? Because of temperature difference called as East Australian current. Warm current है तो उसका effect क्या होगा हमको idea होना चाहिए. It has an important influence on Australian coast, rainfall, etc., etc. This current is flowing southwestward, or it is moving towards south. Why does it move towards south? Because of temperature difference called as East Australian current. Warm current है तो उसका effect क्या होगा हमको idea होना चाहिए. It has an important influence on Australian coast, rainfall, etc., etc. So, should I be dictating this? इसमें dictation की जरूरत है. Pacific Ocean. High enough. Manageable? लिखना चाहते हैं या नहीं, या फिर आगे चले? मैं भी वेट करता हूँ until you say. I'll also wait. मेरे पास भी टाइम बहुत है. Now what I feel कि there is nothing much to write. It's same as what we see for Atlantic Ocean. Only नाम ही तो change होगा. कर लेंगे? Sure? लिखो फिर. No, not लिखो कि कर लेंगे. Southern Hemisphere में, I'll continue with this. Southern Hemisphere, East Australian current, under the influence of west wind drift, it will continue to flow. लेकिन एक जगह पर आकर के कुछ वो same effect, what we call it as Ekman pumping effect, can be seen, and the gyre is completed. This is called as Peru current or Humboldt current. And we know the effect of Humboldt current, dryness, etc., and reinforcement. So I'll repeat, under the influence of trade winds, northeast trade winds are carrying these currents. We call it as north equatorial current. Off the coast of South America, here there will be zone of upwelling and fishing grounds. Then north equatorial current will carry water to the west, south equatorial current carry water to the west. दोनों के पाइलिंग की वजह से एक काउंटर करंट यहाँ पे भी बनेगा. Subsurface current, that is counter equatorial current. Northern part, temperature is high, expansion takes place. Because of that expansion, the Kuroshio current starts moving towards subpolar latitudes. Because of expansion, it starts moving towards southern hemisphere, towards subpolar regions. Kuroshio current causes rainfall. It merges with these currents, Oyashio, Kuril, or coast current, which moves to the north-south of it because of, what is the reason for the movement towards south? Salinity difference and some effect of easterlies also. Polar easterlies का भी कुछ effect होगा, इसलिए आप देखते हैं west की तरफ movement हो रही. Then westerlies, south of that, westerlies are pushing the currents towards west, and they call as Alaskan current. Effect जितना हमें Atlantic Ocean में दिखता उतना ज़्यादा effect यहाँ नहीं दिखेगा. But Alaskan coast will have some influence of the warm ocean currents. The British Columbia region of Canada. This is British Columbia region of Canada. नाम से समझ में आएगा British Columbia. Columbia तो नाम था British Columbia because it had a climate very similar to Britain and it was a territory, it was a colony of Britain. Vancouver जिसका एक major city था. That region will have some moderate rainfall throughout the year because of this current. लेकिन again same, ice melt will decrease the temperature and then it is called as California current near Mexico and California leading to desert formation. Southern hemisphere में south equatorial current flows east to west, East Australian current, a reason for the rainfall in eastern part of Australia, and it plays a role in settlement. West wind drift, Ekman pumping gives rise to formation of Peru current. So this is how Pacific Ocean currents get influenced by various factors. Now we can move to Indian Ocean currents. Indian Ocean currents. Next is effect currents of Indian Ocean. What is the most significant effect of Indian Ocean currents? Next is effect Indian Ocean currents. Next is effect currents of Indian Ocean. the most significant effect of Indian Ocean currents? Reversal, right? Southwest becomes northeast and so on. So एक दो lines लिखो introduction में. Okay, Indian Ocean is unique not only in terms of its extent, but also in terms of effect observed or reversal observed in ocean currents. The reversal is linked to air circulation that reverses seasonally. Full stop. So currents of northern Indian Ocean we can go back to this. Southern Indian Ocean will show the same effect as others. क्या same effect होगा? There will be south equatorial current flowing from east to west, and as it goes from east to west, same effect. Then it will bend towards subpolar regions. It is called as Mozambique current. कहाँ पर Mozambique current बोलेंगे इसको? Mozambique channel में. Mozambique channel is in between Madagascar and the Mozambique in Africa. Further south of that, it is called as Agulhas current. And we know the reason for it. Warm ocean currents can cause heavy rainfall in the region, and same cyclonic effect. Then comes this west wind drift. The west wind drift flows from west to east under the influence of westerlies. Ekman pumping causes separation of this west wind drift called as West Australian current. And we know effect of West Australian current क्या होगा. ये जो warm water है, it flows off the coast of southern Australia. This current that you see, the southern Australia, the bight of Australia, वहां पर ये west wind drift कुछ गर्म पानी लेके जाएगा. Because Indian Ocean southern hemisphere is not that wide. Called as low wind current. Leubwin, low wind current. It's a warm current, almost mixture of Indian and Pacific Ocean, meeting point of Indian and Pacific Ocean, has this warming effect in the southern coast of Africa, Australia. Where, जैसे आप यहाँ Alaska current देख रहे हैं, almost in the same way there will be this low wind current showing some effect in the southern part of Australia. Whereas another part that separates northwards will be having a cooling effect, because we know what is cold for subpolar regions is going to be rather cold for tropical areas will be warm for subpolar regions. तो ये जो warm current है, that will not be that warm for the Australian coast or tropical coast. जैसे Alaska current और California current है, Alaska current and California current will not have a too much of temperature difference in them. लगभग दोनों का टेम्परेचर 10 और 15 डिग्री के सेल्सियस के आसपास होगा. But then 10 to 15 is warm for Africa, it is cold for California. Similarly, tropical part of Australia has cold current. On the western part, don't get confused that कि cold current कहाँ से आया. The cold current is basically a separation of same west wind drift itself. तो west wind drift को यहाँ पर warm कह रहे हैं और हम बाद में cold कह रहे हैं because comparing it to the latitudes, comparing it to the temperature that we see in the Australian coast. So low wind current will remain a warmer current to the southern part of Australia, in the bight of Australia, whereas rest of the current, this west wind drift, is a cold current and we know the effect of cold current. Moving on to the northern part of Indian Ocean. In northern part of Indian Ocean, we know that north equatorial current, as it flows to this east to west movement, western part of Africa, during summers under the influence of monsoon winds, the same current gets carried towards Indian coast to Bay of Bengal. This direction, this current is called as southwest current or southwest wind drift. Southwest क्यों कहेंगे? Because southwest से आएगा. The reason for this movement of the current is because of southwest monsoon winds. These southwest monsoon winds are responsible for carrying the water from the coast of Africa towards India. और जब ऐसा होगा तो obviously यहाँ पर कुछ upwelling of water जरूर होगा. If the surface water is getting carried towards Indian Peninsula, there is going to be upwelling of cold water off the coast of Africa. Clear? Upwelling of cold water off the coast of Africa means fishing grounds, yes. The current is called as Somalian current. At the same time, it means dryness. Right? Semi-arid conditions, desert-like conditions. Because summer time है जब यहाँ पर बारिश होना चाहिए और summer में ही upwelling of cold water हो रहा है Somalian coast में. And that upwelling of water because the surface water has traveled towards India. The Somalian current we know called as Somalian curse. And यही reason था कि सोमालिया में इतना ज़्यादा exploitation हुआ because fishing grounds तो नहीं कहेंगे अपन को लेकिन fishing ज़्यादा बढ़ने लगा. क्यों बढ़ेगा? Because there's a upwelling of water, planktons, etc. The fishing is easy and rich fishing grounds developed during summer time. And exploitation of Somalian resources started because it was easy fishing here in the Somalian coast. And dryness starts. कभी Somalian piracy और ये जो Gulf of Aden में piracy है, इसका history अगर आप पढ़ेंगे, तो history पहुंचाएगा आपको इसी fishing zones पे. Because then Europeans and Americans started coming to this region for fishing. Huge, when overfishing happened, resources got depleted. That is a time when they faced problems. खैर, बाकी आप एक बार पढ़िएगा इसको. Why do these southwest currents become so intense over Indian coast? Southwest monsoon. Why does southwest monsoon become so strong? ITCZ shift to the north. ये सबके लिए होगा, ये यही क्यों है? Intense low pressure can be formed in other oceans also. Why is it only Indian Ocean? Tibetan plateau के कारण क्या बनेगा? Masculine highs. Where is masculine highs formed? Exactly to the south of equator. Indian monsoon में इसको देखेंगे. There's a jet stream theory जो कहता है कि यहाँ पर एक intense high pressure बना. That's called as masculine high pressure. Masculine highs कहते हैं. ठीक south of equator में. From this masculine high, winds will travel towards low pressure. Obviously, low pressure तब कहाँ पर होगा? summers में northern part. So masculine high will push winds across equator because them as equatorial westerlies, very strong winds. So much so that in winds को क्या कहते हैं? What do we call these winds as? जो masculine high से originate होकर के इंडिया की तरफ push होगा, Somalian jets, or we call them as Finleiter's jet. I think we had mentioned this in jet stream, Finleiter's jet or Somalian jets. तो ये वही Finleiter's jet या Somalian jet है जो इस गर्म पानी को इंडिया की तरफ पुश करे जा रहा है. And once it is coming towards India, obviously rainfall will increase. But in African coast, we refer it as Somalian curse. क्यों Somalian curse करेंगे समझ में आ गया? क्योंकि सोमालिया के पास हर वो क्वालिफिकेशन है जो बारिश करवाएगा. नॉर्थ ट्रॉपिकल एरियाज में, ईस्टर्न पार्ट में, सराउंडेड बाय लैंड मास, सराउंडेड बाय वाटर फ्रॉम ऑल साइड्स. नॉर्दर्न साइड से रेड सी है, गल्फ ऑफ एडन है, इंडियन ओशन है. तो हर एक कंडीशन है जो वहां बारिश करवाना चाहिए. फिर भी बारिश नहीं होता है समर्स में, प्राइमरली बिकॉज ऑफ दिस सोमालियन करंट. रिमाइंडेड ऑफ दिस. चलिए नेक्स्ट is about winter conditions. So same discussion that we had in the jet stream, south, or we call that as westerly jet stream. And we have discussed a subtropical westerly jet stream. What is the role of that subtropical jet stream? It intensified northeast monsoon. तो northeast monsoon के कारण reverse effect होगा. This is a time when northeast winds blow over Indian Peninsula, and ये जो northeast monsoon है, northeast monsoon drift, it takes a reverse. Winters में क्यों होगा? Why does it get intensified in winters? ITCZ shift होगा, and ये जो northeast monsoon है, northeast monsoon drift, it takes a reverse. Winters में क्यों होगा? Why does it get intensified in winters? ITCZ shift होगा. एक point हमने jet stream में पढ़ा होगा. Bifurcation of subtropical westerly jet stream. ये bifurcation के कारण high pressure intensify होगा. Because of that intensification of high pressure, winds will blow out of this. इसी को क्या कहेंगे? Northeast or winter monsoon. So because of winter monsoon, they are very strong. So ocean currents will also blow in the same direction as that of winds. उसी को हमने क्या कहा था? Northeast monsoon drift. So इंडिया के साथ ये कहानी क्यों है? Why is it so significant or why is it so unique for Indian Ocean? Is because Indian Ocean के northern side में subtropical high westerly jet stream blow करेगा, that will blow northeast monsoon, and south of that is masculine highs. Those masculine highs will carry equatorial westerlies during summers. तो summer में equator के south में high pressure बनेगा, which will be responsible for pushing winds towards north. और winters में equator के north में high pressure बन रहा है, that is responsible for pushing these winds towards south. That's why reversal actually happens. So एक masculine highs, another is the reason for subtropical westerly jet stream. ये हम पढ़ चुके हैं पहले, इसलिए ज्यादा आपका भी repetition ही है, कुछ नया तो है नहीं. Should we continue this? Everyone clear with this? Chill. So we can finish this discussion on ocean currents then. लिखिए currents of Indian Ocean. 2-3 points लिखेंगे and then we'll summarize this. So first is southwest currents. Southwest currents. During summers, as pressure belts shift northwards, northwards. Southwest monsoon winds blow over northern Indian Ocean northwards. Southwest monsoon winds blow over northern Indian Ocean full stop. Accelerated by cross equatorial jets. These winds drag or carry cross equatorial jets. These winds drag or carry warm water off the coast of East Africa to Indian Peninsula It is called as southwest monsoon drift. Full stop. The flow of water towards northern hemisphere is called as southwest monsoon drift. Full stop. The flow of water towards northern hemisphere causes upwelling of cold water. Full stop. The flow of water towards northern hemisphere causes upwelling of cold water along African coast called as Somalian current. The phenomena brings dryness in the Horn of Africa. The phenomena brings dryness in the Horn of Africa. Dryness in the Horn of Africa, whereas it strengthens southwest monsoon of Africa. Dryness in the Horn of Africa, whereas it strengthens southwest monsoon. Somalian current increases growth of fishes. Because plankton's current increases growth of fishes. Because plankton's come to the surface due to upwelling, come to the surface due to upwelling, that induces growth of fishes. Next is northeast current, northeast monsoon drift. During winters, reversal of winds, winters, during winters, reversal of winds is also translated in the reversal of ocean currents, is also translated in the reversal of ocean currents intensified northeast winds in the reversal of ocean currents intensified northeast winds carry water along Indian Peninsula and merges in counter-equatorial current. Indian Peninsula and merges in counter-equatorial current. The phenomena gets reversed seasonally. Full stop. And related concepts like Indian Ocean dipole or positive phase, negative phase, I presume you know that? Yeah, anyways, we are not discussing it here. Like, ये discussions यहाँ पर नहीं होगा, Indian Geography paper 2 में होगा. GST हम यहीं पर कर लेते because वहाँ कहानी अलग है. Here it will be discussing Indian Ocean and Monarch's experiment and all that. That will be different condition altogether. तो यहाँ पर वैसे भी positive IOD, negative IOD, are we clear with that? Positive IOD is not clear? रिवाइज नहीं किया? कहाँ रहते हैं आप? ले चलो, हम करवा देंगे रिवाइज. But positive IOD, negative we have covered somewhere. मैं बार-बार कह रहा हूँ कि दोबारा करेंगे हम. पेपर 2 में करेंगे, यहाँ नहीं करेंगे. But what is positive IOD? What is Indian Ocean dipole? What is Indian Ocean dipole? Circulation of air. ये डाइपोल है या कोई फेज है डाइपोल का? डाइपोल का पक्का? अच्छा, क्या होगा इफेक्ट इसका जो आपके कह रहे हैं? intensification of monsoon. Why? क्यों? और नेगेटिव हुआ तो why? कहाँ पे? ओके, इंडियन ओशन में चलाते रहो, तीर चलाते रहो, एक तो आसपास लगेगा ही ना, चलाते रहो, बोलते रहो, बोलते रहो। चलो चलो और चलाओ। Dipole, we have just mentioned temperature difference between western part of ocean and eastern part of an ocean. कोई और कहानी नहीं था. Dipole is just one thing. There is just the temperature difference between western part of Indian Ocean and eastern part of Indian Ocean. Western part of Indian Ocean मतलब African coast. ये बस इतना कहानी था. ये line है dipole का. Dipole mentioned again कि opposite conditions है. एक जगह गर्म पानी, air temperature high है, और दूसरी जगह और कोई कहानी नहीं था. दूसरा पॉइंट क्या था इसका? If there is a positive Indian Ocean dipole pre-monsoon, monsoon से पहले positive Indian Ocean dipole है. What is that positive phase of Indian Ocean dipole? Is that there is a presence of warm water along African coast. This coast of Indian Ocean has warm water. लेकिन ये seasons कौन सा है? High temperature, positive phase, temperature is high, pre-monsoonal. Now, if there's a presence of warm water here and there's a presence of cold water in the eastern part, it's considered as positive phase. क्यों positive कहेंगे हम इसको? क्योंकि ये अच्छा है monsoon के लिए. Why is it good? Because this warm water will travel towards India. ये जो Somalian current है, that will upwell here, but the warm water will be carrying towards India, which will increase the rainfall conditions. लेकिन monsoon के time पे, do we have positive IOD? No, it will become either neutral or becomes negative. क्यों? क्योंकि जुलाई के महीने में जब ocean currents northward चल रहा है, the temperature of the coast of Africa is going to be low. Somalian current cold है. तो जुलाई के महीने में अगर वहां cold water है, that is good for India. इसका मतलब क्या है? कि गर्म पानी कहां की तरफ आया है? इंडिया की तरफ. Pre-monsoonal, these days, April के महीने में, मई के महीने में, मार्च के महीने में, it should be positive Indian Ocean dipole. Positive IOD would mean there is a presence of warm water, and when monsoon winds arrive, masculine highs will form. That warm water will be carried towards India, causing higher rainfall. ये positive phase है. Effect क्या होगा positive phase का? Africa is going to get heavy rainfall, sometimes flash floods, dryness in Australia and Indonesia, and cold water conditions. Negative IOD में क्या होगा? Cold water here and warm water in which part? Australia, Indonesia, eastern part, that will get rain. अगर pre-monsoonal ये conditions हैं, before monsoon, if there is a cold water in case of near African coast, now when the masculine highs will be formed, southwest monsoon winds will carry cold water along Indian Peninsula. If the cold water comes along Indian Peninsula, it is going to remain dry, bad for monsoon, bad for Indian monsoon. तो ये monsoon के बाद neutral हो या negative हो, उससे कोई फर्क नहीं पड़ेगा. हमें monsoon से पहले ये क्या रहना चाहिए? Negative. अगर positive, अगर negative हुआ, that means cold water is in Africa. Africa is anyways drier condition. India will also face a very bad monsoon, whereas Australia and Indonesian coast will be receiving higher rainfall. That is negative phase. और in between will remain neutral phase. क्यों neutral phase? जुलाई के बाद हमें कोई ज्यादा फर्क नहीं पड़ेगा. वहां पर वैसे भी टेम्परेचर कम रहेगा. ठीक है. This is about positive and negative Indian Ocean dipole. इसी को हम क्या कहते हैं? See, the eastern part having warmer water than western part. can be called as Indian Nino. जैसे El Nino and Atlantic Ocean. You know, आप लोग exactly वही गलती करते जो मेरी गलती थी. Fair bit of idea, थोड़ा थोड़ा idea और हम आगे बढ़ लेंगे. कुछ ऐसा था, कुछ ऐसा जैसा था. वो जो आइडिया लेकर चलेंगे ना आप एग्जाम में, तो प्रीलिम्स में पहला दिक्कत आएगा और मेंस में कुछ लिख कर आओगे, समथिंग यू राइट, और जब समथिंग में फिर वो मार्क्स नहीं मिलेगा वैसा. गेटिंग द पॉइंट. जब आप पढ़ रहे हैं ना तो उसको एग्जैक्ट पढ़ो, एग्जैक्ट पढ़ो. ऐसा नहीं है कि इंडियन पॉजिटिव आईओडी नहीं पता, बहुत आसान सा कंडीशन है, बहुत आसान सा टॉपिक है ये. तो हमें कुछ आइडिया था कि गर्म पानी कहीं तो होता है, या फिर ऐसे यहाँ पर बारिश होगा वहां नहीं होगा. एग्जैक्टनेस कहां पर आएगा कि गर्म पानी इंडियन कोस्ट तक पहुंचेगा और नेगेटिव फेज में कोल्ड वाटर विल कम टुवर्ड्स इंडिया. दैट इज द एग्जैक्ट पॉइंट. डाइपोल क्या है? अ टेम्परेचर डिफरेंस बिटवीन वेस्टर्न पार्ट ऑफ इंडियन ओशन एंड ईस्टर्न पार्ट ऑफ इंडियन ओशन. दैट्स द एग्जैक्ट लाइन. और एग्जैक्ट लाइंस याद रखो, पढ़ो. आइडिया लेकर चलोगे ज्योग्राफी में तो काम चल जाएगा, वो प्रीलिम्स में दिक्कत करेगा. मतलब बोलने के लिए आपको समझ में आएगा कि हाँ कुछ ऐसा है, आपको ठीक लगेगा, हाँ ठीक है, वी नो, फाइन, वी हैव एन आइडिया. बट प्रीलिम्स विल बी वेरी डेंजरस. और मेंस में फिर वो ना वो नहीं आएगा, वो नंबर नहीं आएंगे वैसे. चलिए, इफेक्ट्स ऑफ ओशन करंट्स. तो इंडियन ओशन डाइपोल, एल नीनो, ला नीना, ये हम यहां नहीं पढ़ रहे. वी आर डिस्कसिंग दैट इन इंडियन ज्योग्राफी. I don't know whether it is mentioned in your books in this chapter or not. दिया है इस चैप्टर में, जिसको छोड़ दीजिएगा अभी. इंडियन मॉनसून करते हैं, उसके बाद फिर हम ये सब डिस्कशंस करेंगे. So effects of ocean currents. एल नीनो तो याद होगा, याद चला गया एल नीनो कहीं और. याद है? मैं पूछूंगा नहीं. I have to trust you people कि you know एल नीनो. क्या है भाई एल नीनो? Uneven heating of or abnormal heating of ईस्टर्न पैसिफिक और पेरू. फिर हम अंदाजा लगा दें या फिर हम कहते हैं कि इट कुड बी बिकॉज ऑफ काउंटर इक्वेटोरियल करंट गेटिंग. चलिए आगे चलते हैं. इफेक्ट्स ऑफ ओशन करंट्स. व्हाट इज द इफेक्ट ऑफ ओशन करंट्स? Right now, first impact on atmosphere and could be because of counter equatorial current getting big. चलिए आगे चलते हैं. Effects of ocean currents. What is the effect of ocean currents? Right now, first impact on atmosphere and climatic condition. चलिए आगे चलते हैं. Effects of ocean currents. What is the effect of ocean currents? Right now, first impact on atmosphere and climatic condition. Ocean currents. What is the effect of ocean currents? Right now, first impact on atmosphere and climatic condition. Ocean currents. How do you see the impact of ocean currents on climatic condition, atmosphere? Point number one, what will be the case? Control on precipitation. Precipitation. Just an example, कैसे इसको लिखेंगे? The presence of warm water causes precipitation. For example, Brazilian coast, Gulf of Mexico, precipitation. For example, Brazilian coast, Gulf of Mexico. Another effect will be cyclones. If ocean currents increase the rate of evaporation, In fact, हमने distribution of cyclones जब पढ़ा, if ocean currents increase the rate of evaporation, In fact, हमने distribution of cyclones जब पढ़ा, तो ये पाया कि जहां warm ocean currents है, वहीं पर cyclones भी हैं. So, occurrence of ocean currents and presence of warm currents coincide. Then another effect on climate, monsoon. Monsoon, for example, positive phase of IOD increases rainfall, negative phase of IOD, Indian Ocean Dipole, decreases rainfall. There is precipitation, there is cyclone, there is effect on monsoon. Moderation भी लिखेंगे, moderation effect can also be seen, for example in case of Europe. Next, effect number 2, navigation. Does it play a role in navigation? How? Then ice-free ports. It maintains ice-free ports in northwestern Europe, and therefore plays a significant role in navigation. It often plays it provides direction to the movement of ships, cargoes, etc. उन दिनों navigate. Then ice-free ports. It maintains ice-free ports in northwestern Europe, and therefore plays a significant role in navigation. It often plays it provides direction to the movement of ships, cargoes, etc. उन दिनों की बात है जहां पर motorized boats नहीं थे, तो ocean currents played a very significant role in to the movement of ships, cargoes, etc. उन दिनों की बात है जहां पर motorized boats नहीं थे, तो ocean currents played a very significant role in navigation. Because the volume of the ocean current is so impactful, if you are going against the current, then the navigation becomes difficult. So it did play a role. In fact, कुछ stories में तो कुछ ऐसा कहा गया कि जब हम ancient times में any sailor who would pass through equator, sailor passing through equator, by default, ocean currents carried the boats towards India because of the flow of the current and flow of the wind. They got direct towards India. So it did play a very significant role in the past, the circulation of ocean currents. So that was one of the role that they played. Third, effect on, we can say, biodiversity. It plays a very significant role in biodiversity. What is the role that they play in biodiversity? One, they increase the growth of planktons. Increase growth of planktons. How? By normalization of temperature and salinity. Temperature or salinity normalize होगा, that is why. Then planktons.
Planktons.
How? By normalization of temperature and salinity. Temperature और salinity normalize होगा, that is why.
Upwelling of water and fishing ground हो जाएगा वहाँ पे.
Then moderation increases biodiversity. As in the regions which have been moderated. Example, Australian region है, जहाँ temperature थोड़ा increase हुआ, circulation is better, coral growth is also better. So moderation and circulation does ensure the circulation of nutrients and gases. Best example are corals. That is one of the effect. Then effect of nutrients and gases. Best example are corals. That is one of the effect. Then effect, economic aspect. First, fishing activities. Fishing grounds developed because of ocean currents, and these regions became fishing nations because of these currents only. Example, you can quote few examples. Fishing activities. Fishing effect, nutrients. Economic aspect. First, fishing activities.
Fishing ground develops.
Fishing activities. Fishing grounds developed because of ocean currents, and these regions became fishing nations because of these currents only. Example, you can quote few examples. For example, Peru, Chile, Japan. Economic activities, they did play a role in trading. Because they maintained these ice-free ports, which was significant for trading. They acted as a major ports. Then economic activities, agriculture, right? Like for example, plantation agriculture across the globe is affected by ocean currents. जहाँ warm ocean currents हैं, we have plantation agriculture, spices, rubber, sugarcane, cotton. These are areas where these crops are grown. Plantation agriculture.
Portuguese का दिया हुआ है. Papaya, pineapple, tomato, tobacco.
Then another effect on human settlements. What about human settlements? For example, human settlements का eastern coast of Australia. At 90% of population lives to the eastern coast because of rainfall. Eastern coast of Australia. At 90% of population lives to the eastern coast because of rainfall. Rainfall कौन cause करता है? Eastern coast of Australia. At 90% of population lives to the eastern coast because of rainfall. Rainfall कौन cause करता है? East Australian current. So it is due to that heavy rainfall that occurs. Most of the cities of Australia are in the eastern coast. Then how does it play in settlement? dispersed settlement. Dispersed settlement in deserts. In deserts. So जितने डेजर्ट फॉर्म हुए हैं वो ओशन करंट्स के कारण जितने भी डेजर्ट फॉर्म है, we can relate that extreme climatic conditions has led to dispersal of human settlements. Right. Such is the impact of ocean current on human settlements or impact of ocean currents overall. अब एक क्वेश्चन यहाँ पर सोच सकते हैं. We are done with this.
ठीक है सर, देख लेते हैं. ब्रेक कट रहेंगे. कॉफी पी लें. ब्रेक कट रहेंगे. पाँच मिनट ब्रेक पे कॉफी पी लें. हाँ, इलेक्ट्रॉनिक पाउडर पीते हैं. introduction to international relation.
I give this question and I get very different answers for it. देखो ocean currents and effects लिखना तो बहुत आसान है. आप structure में लिखिए, atmosphere पर, economic activities पर, agriculture पर, बाकी climatic conditions पे. Because oceans are the regulators of temperature. But if we relate specific to humans, impact of ocean currents specifically to human activities, they say human culture, then I get these answers which are not actually suitable. Ocean currents and human culture. Discuss the impact of ocean currents on human culture. उसमें बहुत अलग-अलग आंसर्स आते और जो आंसर्स थोड़े बहुत relevant भी आते वो like the answers most of you right. Warm ocean currents give rise to fishing. Warm ocean currents cause fall will lead to the death. हमेशा क्वेश्चंस का डिमांड को सोचो कि क्वेश्चन में लिखना क्या है. क्या मुझे ओशन करंट्स पर क्वेश्चन आंसर लिखना है या फिर ह्यूमन कल्चर पे आंसर लिखना है. I have to broadly define human culture. And that broad definition of human culture has some relevance from ocean currents. वो जो human culture के different aspects हैं, वो aspects they are getting affected by ocean currents. What are the aspects of human culture? Food habits. सबसे पहले हम define करेंगे. Way of living. Dressing style, yes, but that is too narrow definition. और सोचिए कि अगर हम देखेंगे way of life, है ना, is or much more definition than that. Lastly, guided by physical activity, physical settings. तो पहला point बनना चाहिए, how do we make our living? Because the way we make our living is largely determining cultural aspect. Festivities are associated with the economic activities. So points should be about economic activities. How do we settle? The point should be about human settlements. Point should be about festivities. Point should be about society. So heading हम क्या देंगे? Economic activities getting affected by ocean currents. So heading will be just economic activities. And then how they are determined, not just affected, how they are determined by ocean currents. Newfoundland अगर fishing zone बना है तो क्यों बना है उसको explain करेंगे. Indian agriculture, then settlements. Somewhere we have compact settlement, tightly packed settlement. Population lives in coastal areas. 16% world का population coastal एकदम coast के पास रह रहा है. Ocean का बहुत बड़ा role है. And at the same time, dispersed settlement in deserts. Then there will be an example for India. Example about Indian condition. India का जो culture है largely monsoonal, agrarian monsoonal. Festivities of India largely influenced by monsoon, and monsoon is directly related to ocean currents. इसके बाद आप खुद से देखिए जहाँ navigation है क्या या वहाँ पर culture में assimilation है क्या? जो कि more assimilation, more mixed culture. देखो mixed culture, diluted culture थोड़े diluted term और थोड़ा negative term है. So intermixing of culture is much more seen in those areas where navigation is better. और खुद से देखिए, खुद से सोचिए कि क्या जहाँ डेजर्ट्स हैं, जहाँ पर नेविगेशन कम है, क्लाइमेटिक कंडीशन हार्श है, क्या वहाँ आइसोलेटेड कल्चर्स बने, मीसो कल्चर्स बने, मीसो कल्चर्स would mean smaller areas, cultures not explicit. पर ऐसा क्यों है? ये बेस्ट ऑक्सीडेंटल कल्चर पूरे वर्ल्ड में चला गया. कैपिटलिज्म, इंडस्ट्रियलिज्म, it's got spread from Western Europe to different parts. थोड़ा सोचिए उसके बारे में. Right? लिखेंगे इसका आंसर? कब? कोई जल्दी नहीं है. I don't want you to write tomorrow. Or I don't want you to write, show me tomorrow. I want you to think properly on this. जितना आप पढ़ सकते हो इसके बारे में पढ़ना. पहले थोड़ा रिसर्च वर्क करना. पढ़ना थोड़ा इंटरनेट के में भी कि कल्चर क्या. Don't go by this what is GPT type. Please don't. Do your own research. मैं आपको बता रहा हूँ नहीं. Sometimes we will be discussing this point. कि क्यों इसको avoid करिए इसको. जितना हो सके उतना avoid करिए. क्योंकि एग्जामिनर के पास भी तो होगा. And trust me for that. और अगर आपको इस पर रेफरेंसेस चाहिए तो मैं वेस्टर्न थिंकर्स के रेफरेंसेस दे सकता हूं आपको. स्टैनफोर्ड यूनिवर्सिटी और ऐसी जगह पर रिसर्च के बाद बहुत सारे डिस्कोर्सेस हैं, बहुत सारे स्पीचेस हैं जो आपको समझ शायद नहीं आएगा कि क्यों इसको मना कर रहे हैं. अवॉइड दिस. डू योर ओन रिसर्च. लगने दो टाइम. क्या दिक्कत है? एक दिन, 2 दिन बाद आंसर लिखो. पर एक आध दिन स्पेंड सम 1 hour in understanding this. Don't type human culture and ocean currents. फिर तो आपको आंसर, रेडीमेड आंसर मिलेगा. Just type about the cultural and western part, geographical impact, or how geography determines the culture of Western Europe. तो पहले point खुद से बनाओ, generate your own points. To substantiate that point, do some work. Research थोड़ा सा, फिर उस बात में रिसर्च. किताबों से पढ़ो, इंटरनेट से पढ़ो, गूगल सर्च जो भी करते हैं आप वो करिए. लेकिन जैसे ही आपने AI टूल्स यूज कर लिया इन आंसर्स को देने के लिए, तो फिर आप डिग्रेडेशन की तरफ जाएंगे. भले टफ लगे, 2 दिन लगाओ, क्या दिक्कत? But do that work. मैं बड़ा मतलब सोच समझ कर इस बात के लिए क्या. और आप भी देख सकते हैं YouTube पे अवेलेबल है. There's a very important India Today ने इंडियन कॉन्क्लेव को कराते हैं. उसमें एक बहुत बड़े प्रोफेसर आए थे. नहीं, about artificial intelligence, he says that people were given, there were 100 students given, some set of students given AI tools, and 100 students were given only Google search and मतलब books to come up with it all. तो जो AI tools रहते थे वो बहुत जल्दी सीख गए. They were very good in learning and learned it, and they took a lot of time. Google search वालों को काफी टाइम लगा. But when it comes to application, AI वाले जो ग्रुप था, they could not apply it in the real world. They could not produce anything much. और जो Google search वाले थे, they did it better in application. So he says one beautiful thing. जो speech में, this harder it is to understand, easier it is to apply. Learning process has never been easy. Learning process has been always hard. It has always been difficult. Always been difficult. But if you are struggling with the learning, you will not struggle with the application. तो राइटिंग के साथ भी ऐसा ही है. Please spend your time. Spend the time. क्योंकि अगर आप साइकिल चलाने में टाइम लगा होगा आपको, 2-3 बार गिरे होंगे, बहुत बार गिरे होंगे, कुछ लगे भी होंगे, बट आफ्टर दैट यू नेवर फेल, क्योंकि सीख गए. तो अब तो रिफ्लेक्स है ना. ऐसा तो नहीं कि सालों बाद भी आप साइकिल चलाएंगे तो ऐसा तो नहीं कि दोबारा से सीखना पड़ेगा, बिकॉज़ यू लर्न. एग्जैक्टली राइटिंग के साथ जैसे इट विल टेक लॉट ऑफ टाइम, वेरी पेनफुल, वेरी वेरी पेनफुल. पेशेंस, टाइम सब जाएगा, लेकिन एक बार आ गया तो फिर आ गया. फिर सो डोंट रश टू. टाइम लगाइए. मैं तो नहीं चाह रहा हूँ आप 12 मिनट में आंसर लिखें, 10 मिनट में, 7 मिनट में, 8 मिनट में. मैं चाह रहा हूँ कि आप 3 घंटे में एक आंसर लिखें. क्या दिक्कत है? लेकिन रिसर्च वर्क करती रहो, ब्रेनस्टॉर्मिंग करती रहो. वर्क. इफ यू राइट 100 आंसर्स लाइक दैट, आई एम प्रॉमिसिंग यू, आप बहुत अच्छा आंसर लिखोगे एग्जाम में. वैसे 7 मिनट वाले 5000 लिखो तो फिर आप क्लर्क बनने के लिए प्रैक्टिस करो. सोच में फिर तो सिर्फ राइटिंग स्पीड करना. सामने डिक्टेशन कोई दे रहा है, आप डिक्टेशन ले रहे हैं. 7 मिनट्स में मुझे अगर आंसर लिखना वो भी प्रैक्टिस कर रहा हूँ अभी मैंने स्टार्टिंग, तो फिर तो मैं सोच कहाँ रहा हूँ. And I'm thinking, I'm taking time. Choice is yours. Anyways, इतना प्रवचन नहीं देना था मुझे. अब 3 घंटे में आंसर है, क्या दिक्कत? लेकिन रिसर्च वर्क करती रहो, ब्रेनस्टॉर्मिंग करती रहो. वर्क. इफ यू राइट 100 आंसर्स लाइक दैट, आई एम प्रॉमिसिंग यू, आप बहुत अच्छा आंसर लिखोगे एग्जाम में. वैसे 7 मिनट वाले 5000 लिखो तो फिर आप क्लर्क बनने के लिए प्रैक्टिस करो. सोच में फिर तो सिर्फ राइटिंग स्पीड बढ़ा रहे ना. सामने डिक्टेशन कोई दे रहा है, आप डिक्टेशन ले रहे हैं. 7 मिनट्स में मुझे अगर आंसर लिखना वो भी प्रैक्टिस कर रहा हूँ अभी मैंने स्टार्टिंग, तो फिर तो मैं सोच कहाँ रहा हूँ. And I'm thinking, I'm taking time. Choice is yours. Anyways, इतना प्रवचन नहीं देना था मुझे. Let's come to waves. Because my preparation goes against the way you be, against your preparation, isn't it? अगर उल्टा जा रहा है मेरा प्रवचन, माइक है, कैमरा है, चलो कोई बात नहीं. अगर अगर एक ही जैसी चीजें आपने सुननी है तो फायदा क्या है ना? कभी 10 चीजें 10 टेक्निक अप्लाई करके देखो, एक तो काम करेगी, जो काम करेगी उस पर चलिए, क्या दिक्कत है? और यू विल अंडरस्टैंड दिस, कुछ दिनों में समझ में आएगा क्यों कह रहा हूं मैं। एक बार करके देखना इस आंसर को, आई डोंट वांट राइट, यू विल राइट। आगे एक काम करना, डू वन थिंग, स्पेंड सम 4 pages at least to write this answer. पहले आप सिर्फ पॉइंट्स जमा करना, जस्ट लाइक ब्रेनस्टॉर्मिंग जैसे ऐसा किया, to be very dirty paper, मतलब ये लिखा वो लिखा वो लिखा। दूसरे में आप उसको अरेंज करना पॉइंट्स दूसरे पेज पर, और दो तीन सेंटेंसेस लिखना कि इस पॉइंट में क्या लिख रहे हैं। देन थर्ड पेपर पे इंट्रोडक्शन कंक्लूजन थोड़ा और फैक्चुअल पॉइंट्स ऐड करना। फोर्थ पेपर पे फाइनल आंसर लिखना, राइट? इस पूरी एक्सरसाइज में आपको कितना टाइम लगा वो फर्स्ट पेज पे लिखना, 1 घंटा 40 मिनट 30 मिनट 10 मिनट whatever time. Stick to all the four, stick to all these 4 papers. पहला जो सिर्फ जो दिमाग में आ रहा है आप लिखते गए, दूसरा अरेंजमेंट वाला, तीसरा इनपुट वाला, और फोर्थ फाइनल ड्राफ्ट, फाइनल आंसर। स्टेपल इट एंड गिव इट, देन यू शो इट टू मी। 4 पेपर्स विद टाइम, और फिर इफ आई गिव माय ओन इनपुट, उस पे थोड़ा काम करना, और फिर सोचना कि फाइनल प्रोडक्ट कैसा आएगा। और अगर आप ऐसा कर गए, टाइम लगेगा, फिर देखते हैं नेक्स्ट स्टेप। नहीं, हम अभी से मना कर रहे हैं। चलो, ये मैं पहले क्लासेस में करवा रहा था, संडेज को यूज्ड टू कम, आई शुड टेक द 6-7 hours class then on writing. तो एंड ये जो मैंने यहां पर करवाया, वन आंसर विल टेक सम 40-45 minutes to write. तो एक 3-4 घंटे में मुश्किल से 5 क्वेश्चंस कर पा रहे थे, 6 क्वेश्चंस कर पा रहे थे, बट टॉपिक कवर हो रहा है। 5 questions are enough to cover, like suppose oceanography, different topics. बट हुआ ये कि यू एक्सपेक्टेड कि मैं आंसर लिखवाऊंगा और आंसर लिखेंगे और आप घर पे जाकर ऐसा कुछ करेंगे, तो वो फिर वो पहले दिन 25-30 लोग थे, अगले संडे को 15 लोग हो गए, फिर 5 लोग हो गए, फिर वो 5 ही रहे, उनमें से 2 इस बार इंटरव्यू दिए। चलिए आगे, waves इंटरव्यू दिए। 5 questions are enough to cover, like suppose oceanography, different topics. बट हुआ ये कि यू एक्सपेक्टेड कि मैं आंसर लिखवाऊंगा और आंसर लिखेंगे और आप घर पे जाकर ऐसा कुछ करेंगे, तो वो फिर वो पहले दिन 25-30 लोग थे, अगले संडे को 15 लोग हो गए, फिर 5 लोग हो गए, फिर वो 5 ही रहे, उनमें से 2 इस बार इंटरव्यू दिए। चलिए आगे, waves. बट इसको ऐसा एक्सरसाइज करना, एक्जैक्टली सेम है जैसे कहा गया। 4-5 पेज को स्टेबल करके दिखाना, और दिखाना कि पहले पेज में क्या लिखा आपने, दूसरे पेज में क्या लिखा, तीसरे पेज में क्या लिखा, फाइनल आंसर क्या लिखा, कितना टाइम लगा। डोंट रश, तो आराम से लिखो। चल, लेट्स सी waves. What is a wave? Disturbance, transfer of energy, and this transfer of energy will take some shape in the form of crest, trough, in the form of compression, rarefaction. That is basically wave. तो sea waves when we refer to sea waves, दिखने में कैसी होती है वो? Transverse, forming this crest and trough wave. Why are sea waves generated? Winds, and then other factors for sea waves. Can be tsunami, can be earthquake, can be a landslide, can be volcanic eruption, can be sometimes gravitational balance between moon and earth. वो भी waves का कारण हो सकता है. Tidal waves हो सकती है. But the most common reason for the wave movement is the prevailing winds. Main reason. So there are 2 forces which act here. One is called as disturbing force. Another is called as restoring force. Disturbing force and restoring force. पानी कितना भी डिस्टर्ब हो जाए, अपना शेप वापस मेंटेन कर लेता है. It takes a drop shape, it becomes that circular shape, sphere shape. Why? Surface tension. One of those elementary topics that you have studied, school days, right? So surface tension को थोड़ा और सिंपल वे में बताना तो क्या कहेंगे? Tension created the surface. That's because every particle is pulling other particle towards itself. अगर मैं सिंपल टर्म में ऐसा सरफेस खिंचा हुआ दिखेगा, क्यों? क्योंकि हर एक पार्टिकल दूसरे पार्टिकल को अपनी ओर खींचे जा रहा है. So one of the simple way, I'm sure आपने भी देखा होगा, that if this is a pool of water or any region, a small spider or some insect can easily crawl over this water surface. See that? Crawl over the water surface. Why is it able to crawl over the water surface? Is because it is acting like a stretched sheet. अगर ये stretched sheet की तरह act नहीं करता, ऐसे porous होता, then crawling would not have been possible. The crawling at the surface of water is possible only when it is acting like this page, when it's acting like a sheet. The पानी sheet की तरह क्यों act करेगा? Is because every particle is pulling another particle towards itself. It's like all of us here in the classroom. If we hold hands and pull each other, तो एक surface सा create होगा. Clear? और crisscross pattern है तो और भी strong surface create होगा. तो surface of water will also be having that attraction. जिसको क्या कहते हैं? Force of cohesion, attraction between similar particles. And it acts as a stretch sheet because of that surface tension, because of that forces that we get. Water tries to restore back its shape. It tries to restore its shape. तो आप disturb करिए पानी को, it will try to come back. Why? How does it come back? Because of that force called as restoring force. Why restoring force? Because there is some kind of a surface tension that we have. So what happens at the coast? If we have this is a coast, like suppose ये मान लीजिए coast है, this is a continent, this is a sea surface, this is a sea surface. Waves reach and then they go back. इसको क्या कहते हैं? Swash. We call it as backwash. तो swash इसलिए हो रहा है because disturbing force है. That disturbing force can be wave, can be wind, can be earthquake, can be landslide, can be any movement that is creating a movement of the water. But what brings it back is this restoring force. पानी वो stretch sheet की तरह act कर रहा है, restoring force. You understanding this point? So, suppose it's a surface of water, and let's throw a plastic ball here, right? और हम imagine कर रहे हैं कि plastic ball का movement कैसे होगा. So if I go by this normal movement, it looks like it should rise, fall, form crest, trough, and so on. और हम wait करेंगे कि ये coast की तरफ पहुंचे. ऐसा स्कूल डेज में अगर तालाब या किसी में वो प्लास्टिक का बॉल गिर गया, then we'll wait that it'll come. ऐसा कभी हुआ कि वापस आ गया? तो only in case of extreme wind movement it can reach. Otherwise it will remain there in the water itself. So when the wind is moving, imagine this movement, wind will push it in the forward direction. लेकिन restoring force कैसा करेगा? Backward. तो disturbing force move it horizontal. Restoring force क्या करेगा? वापस खींचेगा. तो basically it is just rolling. It is just forming an orbital movement. The particle of water is moving this way, forward and coming backward. ये disturbing force के कारण, ये restoring force के कारण. So it's not actually the crest and trough. So when you see this is more like orbital wave. It's more like orbital movement of the water particle. One going forward from the lower part, or restoring force pulling it backward. The particle तो अपनी ही जगह oscillate कर रहा है, and it's moving on its own direction, at its own condition है. So the movement goes something like this. So we do not have exactly the crest and trough. These are basically orbital waves. Why is it orbital waves? Surface will try to move and then come back. तो अगर आप एक प्लास्टिक बॉल बीच में डाल के देखें तो आपको लगेगा ये कंटिन्यूसली रोल करे जा रहा है अपनी जगह पर. क्यों रोल करे जा रहा है? दो फोर्सेस एक दूसरे को अपोजिट कर रही है, एक फॉरवर्ड एंड एक बैकवर्ड मूवमेंट. एंड एज आई गो डीपर एंड डीपर इन द ओशन, द ऑर्बिटल डायमीटर विल कीप ऑन रिड्यूसिंग. क्योंकि विंड का इफेक्ट कहां पर होगा? सरफेस पर. तो डिस्टर्बिंग फोर्स भी कहां लगेगा? सरफेस पर लगेगा. Here, restoring force भी कहां लगेगा? Surface के पास. So if I draw a circle, the biggest circle will be near the surface. The circle will keep on reducing as I go downwards. So what is happening to the particle? It is simply oscillating back and forth. Moves forward, comes backward. Moves forward, comes backward. And as a result of which, these orbital movements will form crest and trough. That okay? Is it clear, this orbital waves or orbital movement? So like any other sea wave, any other wave, so basic properties of a wave ka, like this is the amplitude, this is, what is it called? Wavelength, then there will be frequency. Like you have studied in other waves, exactly the same properties. The maximum vertical displacement will be called as amplitude. The horizontal distance from the crest to trough will be called as wavelength. The time taken will be called as time period in completing one oscillation, and the number of oscillations per unit time will be called as frequency. As a definition of frequency, velocity, wavelength, time period. Right. अब देखना है कि types of waves कैसे होगा और how do these waves move. तो wave movement में कोई भी difference नहीं होगा. That's quite simple, very easy. दिक्कत कहाँ पर आएगी आपको जब आप plunging देखेंगे. Once the wave reaches to the coast, what happens then? तो अब शुरुआत पहले करना है कि waves की properties क्या है. After that we'll see waves in the deeper part of the oceans will be just these capillary waves. Tsunamis भी आपको mid ocean में समझ में नहीं आएगा. When there's a tsunami going on. As we come towards the coast, the wavelength will increase. The wavelength is going to increase, we call them as swells. As we come very close to the coast, not as a wavelength, this amplitude will keep on increasing. amplitude will keep on increasing, and then there will be breakers. तो जब ये शुरुआत हुआ deep seas में, we call them as capillary waves. Capillary waves. Away from the capillary waves, called as swells. As swells reach to the coast, the amplitude increases. They're called as breakers. अब breakers की अलग-अलग type होगी. पहले capillary waves देखेंगे, फिर swells, then we reach up to breaker part, and then we'll see different types of that. But उससे पहले forces को देख लीजिए. What are the forces? I hope you are clear with these forces. So in this movement, actual में क्या हो रहा है? Orbital movement हो रहा है. This is orbital movement. It's all orbital movement. ये orbital movement आप क्या? Why this orbital movement? इसलिए मेरी तरफ देखा करो, दोस्तों में ना बोलता करो, यहाँ देखा करो. So this movement is because of force. What is that force? Disturbing force. Wind. और ये वापस जो movement आ रहा है उसको कौन सा force होगा ये? Restoring force. तो एक particle है जो पानी में है, वो wind उसको आगे ले गया और restoring force क्या कर रहा है? वापस लेके जा रहा है. तो surface से वो आगे गया और restoring force से क्या किया? वापस लाया. तो movement कैसा हो पानी का? Circular हो रहा है. Okay with it? If I use this bottle for a reference, ये पानी का surface है, तो wind is moving it this way, और अंदर से जो resistance है पानी का, वो क्या कर रहा है इसको? वापस ला रहा है. तो surface how forward and what is that? Backward. तो bottle तो कहीं जाएगा नहीं ना? What is bottle doing? It is orbiting at the same point. Bottle is not moving horizontal. The particle of water is not actually having that horizontal movement. It is just rising, coming backwards at the same point oscillating. तो अगर आप ऐसा सोच रहे हैं कि ये पानी coast तक आता है, ऐसा नहीं होता. It's the energy that is moving. तो ऐसा नहीं कि अगर ये पार्टिकल है यहाँ पर कोई डिस्टर्बेंस हो रहा है, तो पार्टिकल वाटर विल बी मूविंग टुवर्ड्स द कोस्ट. फिर तो अभी तक सब कुछ डूब जाना चाहिए. तो बेसिकली व्हाट इज हैपनिंग? ऑसिलेटरी मूवमेंट. एक पानी का सर्कुलेशन हो रहा है, अपनी ही जगह पे पार्टिकल सर्कुलेट करे जा रहा है. इसलिए मैंने एग्जांपल दिया वो प्लास्टिक बॉल का. इफ यू थ्रो दिस प्लास्टिक बॉल हियर, तो कैसा लगेगा हमें? ये फॉरवर्ड जा रहा है और बैकवर्ड आ रहा है. तो विंड उसको आगे लेने जा रहा है, लेकिन जो उसका रिस्टोरिंग फोर्स है, जो उसका विस्कोसिटी मतलब सरफेस से कहेंगे, वो क्या करेगा? बैकवर्ड करेगा. तो बैक इट इज मूविंग फॉरवर्ड, बैकवर्ड मूवमेंट होगा. वेव्स में भी ऐसा ही होता है. व्हाट इज ऑसिलेशन? पार्टिकल इज मूविंग हॉरिजॉन्टली. तो ट्रांसफर क्या होता है? एनर्जी. पार्टिकल का ट्रांसफर नहीं हो रहा है, पार्टिकल इज जस्ट डिस्टर्बिंग, इट इज जस्ट ऑसिलेटिंग देयर ओनली. You understanding this orbital point? So let's write down this basic concept of wave. And waves are disturbances. Waves are disturbances generated. Basic concept of wave. And waves are disturbances. Waves are disturbances generated on the surface of water. Surface of water. And the movement is neither longitudinal nor transverse. Water. And the movement is neither longitudinal nor transverse. Neither longitudinal nor transverse. These are called as orbital waves. Neither longitudinal nor transverse. These are called as orbital waves. These are called as orbital waves. Full stop. The orbital waves keep decreasing with depth. Orbital waves keep full stop. The orbital waves keep decreasing with depth. Orbital waves keep decreasing with depth because there is no effect of wind after a certain depth. Because there is no effect of wind after a certain. Because there is no effect of wind after a certain. Orbital waves keep decreasing with depth because there is no effect of wind after a certain depth. Because there is no effect of wind after a certain depth. Full stop. These orbital waves, because there is no effect of wind after a certain depth. Full stop. These orbital waves orbital waves are generated when two forces act upon water surface. Number one is disturbing force, that is mainly wind, disturbing force, that is mainly wind. Number two is restoring force, that is mainly the surface tension. Number two is restoring force, that is mainly the surface tension. Full stop. As winds blow over the surface of full stop. As winds blow over the surface of oceans, the energy gets transferred. As winds blow over the surface of oceans, the energy gets transferred to the water surface. Creating forward movement of the particle. Restoring force, creating forward movement of the particle. Restoring force acts opposite to it. Restoring force acts opposite to it, creating backward movement of the particle. As a result, creating backward movement of the particle. As a result, an orbital movement develops, decreasing towards deeper layers. Take a subheading, wave motion, and we'll discuss these movements. How does movement take place in waves? Let us be in deeper part of oceans. हम पैसिफिक ओशन या किसी भी सी के सेंटर में चले, वहां पर हमें एम्पलीट्यूड का पता नहीं चलेगा, because disturbing force is not always wind, it can be other disturbing force also. अगर सुनामी भी चल रहा है तो हमें नहीं पता लगेगा. Why? Because amplitude is not going to be very high. The speed could be high. देखो मैं वो definitions नहीं आ रहा हूँ. I'm not discussing the speed, frequency. I'm hopeful that we know what is speed, what is amplitude of the wave. We will not see a very high amplitude waves there. Proper, deeper part of sea, deeper part of oceans. Speed could be higher, right? Intelligent class. How do we measure the speed of an oscillatory waves? Yeah, movement. Speed is what we call it as distance upon time, wavelength upon time. लेकिन अगर हम ऑसिलेशंस देखें, वो हार्मोनिक मोशन देखें, तो कैसे कैलकुलेट किया था हमने वेव्स को, स्पीड को? ऐसा कुछ था, GH speed is equal to under root of GH. H here means amplitude.
And G means gravity.
मैंने गलत पढ़ा. Because when you look at the simple movement of the wave, or speed of the wave is easy. Wavelength, let's say wavelength upon time will be called as speed. है ना? फिर मैं पूछूं wavelength क्या आप कहेंगे? Speed into time is wavelength. फिर उसको टाइम पीरियड क्या है, फिर आपका स्पीड अपॉन वेवलेंथ, ये कहानी चलता रहेगा, छोड़ देते हैं इस बात को. But velocity of a wave is also measured as under root of acceleration due to gravity and amplitude of the wave. Particularly when you look at this transverse waves, या वो pendulum ऐसा कुछ था, या सिर्फ मैंने कुछ ठीक मुझे भी याद नहीं आ रहा, बहुत पहले की बात है तो मैं ज़्यादा याद नहीं कर पा रहा हूँ, कुछ ऐसा ही कुछ. Anyways, आगे बढ़ते हैं. तो speed, just for interest sake छोड़ दो, wave छोड़ देते, क्या करना है wave पर. So if I consider speed is somewhat like this, जब depth ज़्यादा है, the depth is higher, because here in oceans we will not be looking at the amplitude much. किस पर देखेंगे हम? Depth of the ocean, the speed can be higher, right? और अगर मैं speed को कम करूँ, to conserve that energy, what should increase? Height should increase. अगर मैं speed कम कर देता हूँ oceans का, like suppose if I decrease the speed of the wave, कुछ तो conservation of energy होता है. अब एक momentum और ये सब पर नहीं जाऊँगा, मैं एक simple logic as a layman, मोटा-मोटा अगर मैं समझूँ, तो ऐसा नहीं कि speed एकदम zero हो जाएगा. There will be ocean will try to conserve that energy, speed. तो अगर speed कम हो रहा है, किस में translate होगा? G तो constant रहेगा. What is going to change? H is going to change. H will change. अगर speed कम होगा to conserve that, H should increase. So if the speed is higher, will H be higher? Or that is it going to be higher? No. चलो छोड़ो, इस पर क्यों इतना परेशान हो? हम depth of the ocean में चलेंगे. ये बताइए कि यहाँ पर wave का speed ज़्यादा होना चाहिए, कम होना चाहिए? कम. Should it be higher in the deeper seas or shallower seas? Deeper seas. Why deeper seas? OBR के साथ friction नहीं है. It does not interact with ocean bottom waves because water is much deeper. So if it is faster, H is going to be smaller. Or amplitude of the wave is going to be smaller. तो जब deep sea में आप देखते हैं जहाँ पर ये waves का generation शुरू हुआ, winds के impact में आकर के, speed of the wave is going to be faster. You're clear with this? Sure. Will amplitude be higher? Amplitude कम होगा यहाँ पर. If amplitude is lesser, initially these waves are called as capillary waves. Capillary. उनका wavelength भी कम है. 2 सेंटीमीटर से कम होगा. They're called as capillary waves. So this is where the wind is showing its impact. Initial waves. This is wind showing its impact. Small amplitude waves are formed, called as capillary waves. When you move out of this capillary waves, when you're moving far away from the deeper part, तो ये सब energy इकट्ठा होगा. All that energy is getting to pile up, and then long wavelength waves are created with a fairly higher amplitude. We call these waves as swells. So in the initial stage of the wave formation, how is particle moving? What are these waves referred as? Capillary waves. जिनका amplitude बहुत ज़्यादा नहीं होगा, speed is going to be higher, and frequency is going to be higher, तो wavelength कम होगा. Smaller wavelength, we call them as capillary waves. तो winds ने जब वो like impact दे दिया, when it is moving further, you'll see that waves have increased, the wavelength has increased, amplitude is also rising a bit because of that continuous accumulation of energy from all regions. Those regions are called as, that part of the wave is referred as swells. अब यही swell जब coast पर आएगा, the same swell when it reaches to the coast will form breakers. मैं breakers पर अभी नहीं आना चाह रहा, breakers पर हम बाद में आएंगे, but should understand what is happening in the swell. Swell में वो orbital movement होता है, वो it's taking place in that, so and then long standing waves are formed. यही disturbance जब coast तक पहुंचेगा, कैसे energy is going to decrease, rather the speed of the wave is going to decrease. क्यों? Friction generate होता रहेगा. किसके साथ? Coast के साथ, continental shelf के साथ. If the friction is decreasing, the speed is decreasing, what will happen to amplitude? Rise. That's why when you stand at the seashore, you find a very high wave reaching there. Wave का amplitude ज़्यादा increase, ज़्यादा होगा. कहाँ पर? Coast के पास. क्यों ऐसा होगा? We'll see that. पहले swells पर चलते, sorry, capillary waves पे चलेंगे. After that we'll reach up to swells. Not clear with this? Why the speed is deeper? Why speed is higher in the deeper seas? Because friction नहीं है. So greater depth, higher speed, and then we'll continue from there to reach to swells. तो wave motion में लिखिए पहला point. The forward movement of the wave, पहला point. The forward movement of the wave, is created by disturbances. The wavelength of such initial waves by disturbances is created by disturbances, the wavelength of such initial waves, the wavelength of such initial wave is the wavelength of such initial waves, the wavelength of such initial wave is less than 2 centimeters, is less than 2 centimeters. These small waves are called as capillary waves, are called as capillary waves. Such waves are destroyed by surface tension, are called as capillary waves. Such waves are destroyed by surface tension. Such waves are destroyed by surface tension. Speed of orbital waves decreases with depth. As the movement continues, the surface gains more and more of energy. Surface gains more and as the movement continues, the surface gains more and more of energy. Surface gains more and more of energy from the wind blowing over it. From the wind blowing over it. From the wind blowing over it. From the sea. Surface gains more and more of energy from the wind blowing over it. From the wind blowing over it. Waves increase in height and length. Wave increase in height and length resemble to sine curve. Resemble to sine, S-I-N-E. Wave increase in height and length resemble to sine curve. Resemble to sine, S-I-N-E, sine curve. Resemble to sine curve. Resemble to sine curve. Resemble to sine, S-I-N-E, sine curve. Resemble to sine curve. Such waves are also called as gravity waves. Such waves are also called as gravity waves. Also called as gravity waves. So these are distinguished from capillary waves. These are distinguished from capillary waves, also called as gravity waves. So these are distinguished from capillary waves. These are distinguished from capillary waves as these are having rounded crest and trough. These are distinguished from capillary waves as these are having rounded crest and trough. Rounded crest and trough. The height is directly observed. The height, rounded crest and trough. The height is directly observed. The height is directly controlled by amount of energy. Observe the height is directly controlled by amount of energy amount of energy gained from disturbing force. Gained from disturbing force. Next heading, swells. Swells. If waves move out, swells. Swells. If waves move out, if waves move out from the margin of generating or wind area, generating and wind area, the supply of impact, the supply of energy or wind area, generating and wind area, the supply of impact, the supply of energy is cut off. Is cut off. The supply of impact, the supply of energy is cut off. Is cut off. And the wave is subjected to loss of energy. Loss of energy. The time period and wavelength. Time period and loss of energy. The time period and wavelength. Time period and wavelength. Loss of energy. The time period and wavelength. Time period and wavelength is relatively longer. Is relatively longer. These are called as swells. 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 So swells travel. Swells travel over large open. So swells travel. Swells travel over large open areas, large open oceans. As soon as they reach to coast, the velocity decreases. The velocity decreases due to decrease in depth. The velocity decreases. The velocity decreases due to decrease in depth. Decreases. The velocity decreases due to decrease in depth. Decrease in depth. Also, let's keep it simple. Then we'll come to breakers. So let's think here. आप कभी तो वाटर पार्क में गए? Everyone? जब कभी नहीं गए, हम चलो कभी बड़ी वाटर पार्क जाएंगे. ये तरीका पढ़ाने का. ये कुछ बोल रहा है. ये कुछ तरीका है क्या पढ़ाने का? हम वाटर पार्क जाएंगे. समझ गए? This is the artificial wave that produce. You experience that? Sure. क्या होता है उसमें experience? वो वहीं से एक पूल सा होता है कुछ पानी ऐसा. They keep the slanting. Slanting तो चलो छोड़ो. As you go towards the deeper part of it, you'll see that जब वो wave produce कर देते हैं, so there's a sudden push of water and then they stop it. ऐसा होता है. There's something that pushes water outwards. तो उसके बाद क्या होता है? वो अपने आप rise करेगा. And there's no supply of energy there. अगर energy supply करते रहते तो वो rise करेगा क्या? तो क्या वो horizontal movement ज़्यादा करता है भाई? Vertical. चलो क्या? घर पे जाकर एक टेबल फैन लेना and keep a pool of water in front of it. टेबल फैन को on off करते रहे. When you provide energy to the water, तो क्या होगा? छोटे-छोटे ripples बनेंगे पानी के ऊपर. Right? Switch it off. जब वो ripples travel कर रहे हैं, कुछ देर जाने के travel करने के बाद वो ripples slow down होंगे. Here, but at the same time, you can see the rise in amplitude and wavelength. That is called as swells. वो भी नहीं, ये भी clear नहीं हो. एक काम करना, observe करना, किसी दोस्त को बोला बहुत बड़ा पत्थर किसी लेक में डाल दे बीच में.
right? Observe it after that. After that, water will keep on moving. तो छोटे-छोटे ripples बनेंगे यहाँ पर जहाँ पर पानी drop हुआ है, जब वो पत्थर drop हुआ है, right? किनारे पर जाने पर क्या होगा? एक waves आएगा. क्या होगा उसका? तो ध्यान से देखना तो wavelength increase किया होगा, and the speed will be lesser. तो जहाँ पत्थर drop हुआ है, what happens there? Faster movement, much like capillary waves. दूर जाने पर वो wave complete सा दिखा, तो क्या कहा? Waves can you travel up to greater distance. तो जितना वो दूर जा रहा है यहाँ से, तो energy यहाँ पे drop हुआ, is going away from it. तो speed will decrease, but at the same time wavelength is increasing. तो that rise को क्या कहेंगे हम? Swells. Not clear? इतनी एग्जाम्पल के बाद तो पानी बहुत है, आप पूछ सकते हैं. We will observe that. Right? So this वो जो अपना water park में they create this wave, something like this, ऐसा कुछ डिजाइन होता है. तो यहाँ से they push this energy very close to that, you will not see much impact. यहाँ पर थोड़ा ripples बनेंगे. And then they cut off this energy supply. ऐसा energy supply दिया और cut off किया. अगर वो continuous energy supply देते रहेंगे, तो what will happen? It will create ripples all over. तब तो waves बनती दिखेगी. But that sudden increase will not be there. वो सारे increase will क्या होगा? तो moment they give this energy, they cut off. तो waves कुछ देर बाद कैसी बनेंगी? Slow but greater amplitude of wave. So you'll find that there is a sudden rise. वहाँ तो क्या कहेंगे इसको? Swells. तो अगर आप समझदार होंगे, तो यहाँ कहीं खड़े रहेंगे, you can see that impact. अगर डाउन है, तो यहाँ चले जाएंगे. Then you'll see कि हाँ धक्का लगा ऐसा एनर्जी आ रहा है, but you'll not see the rise in the water. वो सब इसलिए होगा because पानी वहाँ गहरा है. You'll not experience waves. Experience wave कहाँ पर करेंगे आप? Towards the end of it. Clear? I took my kids to this school. वहाँ मैं उनको ये concept दे रहा हूँ. After that ऐसे हमको जाना ही नहीं. I'm too young to understand anything like that. But I tried कि चलो swell बना लो. And we don't want to go. हमको dinosaur park में ले चलो. We'll go to any museum, preferably, but not to water park next time. Right? Jurassic Park? Dinosaur वो कहीं ना कहीं film देखकर ना वो they learn something. पर वाटर पार्क में आप जाएंगे तो खेलने कूदने जाएंगे ना, राइट? ठीक है. ये मेरे तरीके होते हैं कि I want to spoil enjoyment. क्लियर? तो प्लानिटेरियम में कहीं जाएंगे, wherever they wish to go. ठीक है, नेक्स्ट टाइम वो कभी नहीं कहते हमने जाएंगे. We are happy. इधर है, मार्शल एंड द बेयर इज ओके, कोई लॉजिक नहीं है. आप भी सीखना चाहते हैं ऐसा? तो वाटर पार्क चले, is it? But you will understand that swell. अब करें इसको. Swell से भी खतरनाक टाइम आया. यहाँ पर, where the wave is further increasing. So amplitude is increasing here. When I'm drawing it here, amplitude is increasing this region. Can I say this orbital will keep on decreasing? पूरा orbital movement नहीं हो पाएगा. क्यों? क्योंकि ऊपर तो एनर्जी है, पर नीचे एनर्जी होगा क्या? Will the energy be there in the lower part of it? No. Why? Because friction will keep on increasing. तो जैसे जैसे waves यहाँ तक आया, तो lower part is slow, upper part is higher. तो amplitude क्यों बढ़ रहा है? ये समझ में आ रहा है? Because वो जो energy लेकर आया wave, lower part is not supporting it. So what will happen is amplitude is increasing. That's why tsunamis or waves are always observed at the coastline, not at the middle of it. Why? Because when the energy is traveling, lower part will be having lesser speed, upper part में पानी pile up होता रहेगा और height increase करेगा. इसको कुछ इस तरह से लेके जाएंगे आपको मजा आ जाए. Suppose we are running, let's say I am running, or anyone of us running fast, and someone holds my feet and pull it backward. क्या होगा? मजा आ गया? Clear? इसीलिए जब आप वो पाँव छूने आते ना, मुझे लगता है बस यही करने आ रहे हैं. ऐसे I avoid it, दूर हो. Right? Don't embarrass me. Understood everyone?
Yes.
Waves के साथ भी तो ऐसा ही हो रहा है. What is amplitude has increased? Upper part is trying to move faster, which it can. Lower part में क्या हो रहा है? Friction increase कर रहा है. So if friction is increasing, this will plunge. Upper layer is going to fall down. क्यों? क्योंकि उसको नीचे का support नहीं मिल रहा है. It is not getting that support. Why not support? Because lower part is getting slower. If it is getting slower and upper part is having higher speed, it will fall almost like a waterfall. Yeah? It is almost going to fall over. So जहाँ wave, that amplitude is incomplete, that sine curve is incomplete and it falls. That line is called as plunging line.
Plunging.
Frustration नहीं रखो. हर चीज मजे की थोड़ी आएगी. What is that called? Plunging. You understand that? The water when wave is plunging. Why is it plunging? Because the lower region is not moving with the same speed. Upper is moving with a greater speed. तो जो rise किया है, it is not finding the support at the base. तो क्या करेगा? Plunge. Will wave continue? क्या वो sine curve complete हुआ? No. क्या कहेंगे इसको फिर? Breaker. The line is called as plunging line. Where wave discontinue, but where the process of that region, that wave is called as a breaker wave. The line is called as a plunging line. जहाँ पर wave टूटना शुरू हुआ, और जहाँ टूटना शुरू हुआ, वहाँ से पानी निकलना शुरू होगा. So we have a spilling breaker, we have a plunging breaker. But here, the continuity of the wave is going to disturb. Why is it going to get disturbed? Is because upper movement is faster, lower movement is slower. So this upper movement of the water is not getting the support of the base. तो continue कर पाएगा wave? क्या होगा फिर? टूटना शुरू होगा. Continuity of the wave will start breaking. जहाँ पर ये टूटना शुरू होगा, wave is breaker, and the line is called as plunging line. Then, if the the depth was maintained, suppose the depth was maintained, कभी जब टूटा, it would have gone on continuously, लेकिन depth चूंकि कम होते जा रहा है और friction बढ़ते जा रहा है, the wave is going to have that downward movement, the wave is going to have that plunging movement. तो अब वो crescent का बन पाएगा क्या? क्योंकि crest बीच में टूट गया. Then okay, टूटने का कारण समझ में आया क्यों? Lower part slow, upper part fast. तो ये amplitude तो बनाया लेकिन इसको वो plus नहीं मिला. Then it will fall down. Final. Orbital पूरा होगा या incomplete होगा यहाँ पर? Incomplete होगा. तो सिर्फ crest दिखेगा. Done. देखिए next line breakers. Continue करिए उस discussion को. Take the heading breaker. B-R-E-A-K-E-R breaker. Once the wave slows down, take the heading breaker, B-R-E-A-K-E-R breaker. Once the wave slows down, near to the coast, the following wave is moving at a velocity near to the coast. The following wave is moving at a velocity to the coast, near to the coast. The following wave is moving at a velocity unaffected by shallow waters. The height of the wave increases, unaffected by shallow waters. The height of the wave increases. Because due to the height of the wave increases. Because due to decrease in speed, crest gets narrower. Because due to decrease in speed, crest gets narrower. Amplitude increases. The slowing down of the base of the wave. The slowing down of the base of the wave breaks the continuity of the sine wave. S-I-N-E, sine wave. Sine wave would mean this crescent trough. Sine wave. S-I-N-E, sine wave. You understand sine wave? Continuity of the sine wave. The wave is called as breaker. That is where sine wave. The wave is called as breaker. That is where the crest of the wave breaks. That is where the crest of the wave breaks. Comma, the line where it breaks. Crest of the wave breaks. Comma, the line where it breaks. Is called as plunge line. P-L-U-N-G-E, called as plunge line. So breakers can be of different types. called as plunge line. Breakers or breakers. Called as plunge line. Breakers or breakers can be of different types. Breakers can be of different types. Can be of different types. Breaker को पहले clear करते हैं. We are clear with breaker. आप किनारे पे खड़े हो, you're looking at the wave reaching towards you, और फिर अचानक से देख रहे हैं आप wave को continue करना था, लेकिन wave बीच में टूट गया. वो क्यों टूटा ये clear? Same way जो मैंने example दिया, अगर पैर को खींचेंगे तो गिरेंगे जरूर. Forward में. तो wave जो continuous movement हो रहा था, नीचे का पानी slow down हुआ, ऊपर का पानी अभी भी fast है तो it doesn't find that support to fall down, and then it will spill over. So क्या is surfing possible at every coast? No, there are particular coasts where surfing is done. कहाँ पर होता है surfing ज़्यादातर? But not a place. What is the nature of the wave in surfing ज़्यादा होता है? Is the wave tide higher or lower? अच्छा वो surfing waves देखा आपने वो fine जहाँ surfing करते हैं तो देखा कि वो टूटता है. The wave is not continuous. See, I don't have pictures ready. कल मैं आपको ये pictures कुछ दिखाऊंगा तुम्हें. कुछ इस तरह का wave बने. It will not be continuous here. So there will be curved movements and it is just plunging. और इसी तरह से waves होगा जो just spill over the surface बड़े शरीफ तरह से move करेगा. Now क्या? So breakers can be different type of breakers. One is plunging breaker, one is spilling breaker, and one is surging breaker. Plunging breaker is just like the waterfall, this curve falling over, जहाँ पर surfing होता है. Surging breaker will be, yes, the water level will increase, the slope is very steep. And then there's spilling breaker, where there's a gentle slope. The wave will come and form this foamy, frothy feature and just spills over. उनको spilling breaker कहेंगे. So तीन तरह के breakers. अब ये breakers कैसे बनेगा? What will it be dependent on? Slope. Continental shelf की conditions कैसी हैं? Continental shelf कैसा है? Is it steep? Is it very gentle? Or is it very, very steep? And there's a sudden steepness, something like that, much, much steeper than this. They will determine type of breaker. Because when the wave is reaching, तो बहुत आराम से ये टूटेगा, बिखरेगा, या plunging करके बिखरेगा. That all depends upon what is the nature of the continental slope or coast का nature कैसा. Steep है, gentle है या बहुत ज़्यादा steep है. That is how it will form. क्या लगता है आपको कौन सा कहाँ पर होना चाहिए? Spilling breakers कहाँ पर आने चाहिए? Gentle slope. Water will come to the surface. Gradually, it will decrease. The speed will decrease gradually. और surface तक आते आते पानी का volume almost खत्म हुआ होगा. Because when suppose it's a gentle slope here, तो wave reaching यहीं से इसका speed कम होना शुरू हुआ. Gradually, speed decreases. Gradual speed decrease would mean by the time it reaches the coast, it will be having lesser speed and just spill over. लेकिन अगर steep slope है, then there can be plunging breakers or surging breakers. Why sudden speed? Is because the wave was complete, but slope चूंकि एकदम से change हो गया, तो नीचे की layers slow हो गई, ऊपर की layers अभी भी तेज है, it will fall as a plunging breaker or surging breaker. लेकिन अगर gentle slope है, पहले से ही speed कम होते जा रहा है, right? It's a gentle slope, so by the time it reaches to the coast, it will just form a foamy, frothy feature. इसको we simply call it as surging, no, we call it as spilling breakers. The breakers will be of three types, depending upon coastlines. तो पहला क्या होगा? Spilling breakers. Write down spilling breakers. Spilling breakers. Water doesn't fall, but gradually spills in front of the wave. Water doesn't fall, but gradually spills in front of the wave. Water doesn't fall, but gradually spills in front of the wave. Gently sloping seashores form such breaker. Gently sloping seashores form such breaker.
Plunging breakers and surging breakers.
Breaker. Okay, foaming coasts. Foaming coasts develop. Breaker. Okay, foaming coasts. Breaker. Okay, foaming coasts. Foaming coasts develop. Breaker. Okay, foaming coasts. Foaming coasts develop. Foaming coasts develop. एक लाइन अगर आप समझ पाए तो spilling breakers are formed. Spilling breakers are formed. Spilling breakers are formed when the crest and deeper part has same velocity. ये समझ में आ गया? तब तो कोई इतना ज्यादा वो फॉल नहीं होगा. Gradually it is going to decrease. Right? तो ये वही breaker है, ये वही coastline है. This is suppose the coastline and these waves are coming toward the surface and then just spilling over. Very शांत coastline होगा, बहुत ज्यादा disturbance इसमें नहीं होगा. Quite gentle slope. तो ये वही coast है जहाँ पर आप जाकर के नाम लिखते हैं. And then कुछ ही देर में उसके ऊपर पानी फिर जाता है. चलिए आगे. Spilling breaker. Next time when you write names, spilling breaker समझना. The waves will be very gentle and go away. Shall we continue? Next, plunging breaker. Plunging breaker. Water falls nearly vertically. Breaker. Water falls nearly vertically as it rushes towards the shore. Full stop. It forms a turbulent flow of water. The shore. Full stop. It forms a turbulent flow of water. Upper part of the crest flow of water. Turbulent flow of water. Upper part of the crest moves faster than the lower part or deeper part. So along steepest in the lower part or deeper part. So along steeper slopes, deeper part. Then the lower part. So along steeper slopes, the wave energy becomes insufficient. Key point ध्यान से समझना. Wave energy becomes insufficient to support the curling crest. Curling, C-U-R-L-I-N-G, curling crest, C-R-E-S, becomes insufficient to support the curling crest. Curling, C-U-R-L-I-N-G, curling crest, C-R-E-S. You clear with this? Upper part is moving. The curling crest, C-U-R-L-I-N-G, curling crest, C-R-E-S. You clear with this? Upper part is moving faster, lower part is slow. So अगर इसको coastline समझें, so the waves will be somewhat like this. Upper part moving faster and then it plunges on the coast. We call them as plunging breakers. So moving this part. Can you visualize this happening? Right? This is slow. Upper part is faster. That is plunging. ये वो surfing वाला coast होगा. And wave height is going to be very high. Next is surging breaker. These are gentle waves, and wave height is going to be very high. Next is surging breaker. Surging breaker. These are gentle waves. These are gentle waves. Water moves rapidly towards the coast. Water moves rapidly towards the coast. That is steeper, but the height of the crest is relatively lesser. Height of the crest is coast. That is steeper, but the height of the crest is relatively lesser. Height of the water moves rapidly towards the coast. That is steeper, but the height of the crest is relatively lesser. Height of the crest is relatively lesser. So along steeper coast, lesser. So along steeper coast, यहाँ पर भी ऐसा plunging सा बनेगा, but not as much as what we have here. Right? इस केस में क्या होगा कि ऊपर का part बहुत तेज है, then lower part we have a much higher, you can say the amplitude. In this, the amplitude is not going to be very high. These are called as surging breakers. This will be plunging breakers, and here it is spilling breakers. तो surging breakers भी कभी plunging breakers बन सकते हैं. If the wind speed is very high, cyclonic case में, or the wind speed is very high, there will be surging breaker converting into plunging breakers. Conditions दोनों की same है, steeper slopes. Lock करें इसको. You are trying to draw this. इसको properly draw करो. Same speed between the deeper part and lower part. This is the coast. Same speed, upper layer and lower layer. This is faster and this is slower. Again, faster and slower, but crest is lesser. तो सर्जिंग ब्रेकर में भी डिफरेंस होगा स्पीड का, पर बस इतना है कि बहुत ज्यादा इंटेंस मूवमेंट नहीं है. ओके, फिर एक और टर्म आता है सीश. सुना है? SIECHE, सीश. यहां तक क्लियर? So when you next time see the wave, go to the deeper part और wave के साथ कोस्ट की तरफ आते रहना. तो पहले कोई इम्पैक्ट नहीं दिखेगा आपको. Whatever boat that you're riding will be normal speed, like not very intense. Capillary waves हो. कुछ देर बाद थोड़े बढ़ने लगेंगे. They call it gravity waves. फिर उसके बाद ऐसा लगेगा स्पीड तो कम हो गया लेकिन एम्पलीट्यूड वगैरह बढ़ गया. That is swells. And when you reach the coast, you may have any of these three options near the coastline. Sea सुना कभी नहीं? देखा एक ऐसा वाटर बॉडी जिसमें एक तरफ से पानी आया दूसरी तरफ से पानी चला गया. वाटर रिमेन्स कांस्टेंट. There's a wave carrying water to the water body, but it spills over from the other side. जैसे for example information to two people. There's a wave of information going और एक information निकल गया. Information remains constant. That pool is called as sea. That movement of wave is called as sea. ठीक है, मैं कल बताऊंगा. You know about the node? कल डिस्कस करेंगे. Don't इतना परेशान नहीं हो. Because tomorrow's discussion is going to be disturbing. कल disturb हो जाएंगे आप by the time classes end. जो waves होगा like tides and theories of the tide, उसमें थोड़ा बहुत दिक्कत आने का chances है और आएगा भी उसमें दिक्कत, कोई बात नहीं. उतना तो हम चलें. Right, so I'll see you tomorrow with a discussion on tides. We will also be looking at coastal landforms. Tides करने के बाद emergent coastlines, submergent coastlines and coastal landforms. उसके बाद फिर coral reefs specific. I'll see you tomorrow then.
Hello and welcome to Clarity for UPSC. I am Dr. Shivan. Building a sustainable study routine is a big challenge. हम सबको पता है कि हम अपना स्टडी रूटीन ये सोच के बनाते हैं कि हम दिन में 12 से 15 घंटे पढ़े जाएंगे. पहले एक दो दिन शायद हम कर भी लेते हैं, बट देन वी आर बैक टू स्क्वायर वन. वही 2 घंटे 4 घंटे, मॉर्निंग इज अनप्रोडक्टिव, कोई शेड्यूल नहीं है, एंड देन वी एंड अप फीलिंग डिप्रेस्ड. फिर क्या होता है, अपना जो पुराना टाइम टेबल है उसको तोड़ो, फाड़ो और एक नया टाइम टेबल बना के स्टार्ट करो. ये प्रॉब्लम इसलिए आती है क्योंकि हमारे स्टडी रूटीन जेन्युइनली सस्टेनेबल नहीं है, राइट? दे माइट बी वेरी हाई अचीविंग, दे माइट बी वेरी एम्बिशियस, बट दे आर डेफिनेटली नॉट सस्टेनेबल. देखो यार, फैक्ट है कि इस एग्जाम में ना बहुत फेजेस आते हैं. राइट नाउ द प्रीलिम्स इज फार अवे, मेंस की पढ़ाई भी ऑलमोस्ट लोगों की खत्म हो रही है, एंड
ब्रेक टाइम है, कॉफी पीते हैं.
lean phase in this exam. तो ये वीडियो शायद मार्च और अप्रैल में उतनी रेलेवेंट नहीं होगी आपके लिए, राइट? बिकॉज उस टाइम पे सब पढ़ लेंगे, सबको दिख रहा होगा कि देखो एग्जाम सामने आ गया। बट ये जो लीन टाइम है ऑफ दिसंबर, ऑफ जनवरी, जब विंटर भी होती है नॉर्थ इंडिया में एंड इट्स वेरी डिफिकल्ट टू पुट इन द आवर्स, इस टाइम पे जो लोग पढ़ते हैं दे आर द वंस हु एक्चुअली मेक इट। Now this is also the time when we need to have a sustainable study routine. ऐसा भी ना हो कि हम बहुत ज़्यादा burden हो जाएं, कि मार्च अप्रैल तक हम burnout ही हो जाएं, but ऐसा भी ना हो कि ये time waste हो। And in this video I'm going to talk about how you can build that sustainable study routine. पहली बात करते हैं that how does our brain work, right? अभी इस बात को admit करने में I'm sure openly शायद आपको problem होगी, but मुझे तो आप बता ही सकते हो। जब हमें सामने दिखता है कि यार एक एग्जाम है, या हमने देख लिया कि देखो हमारे रूममेट का एग्जाम क्लियर हो गया, या हमारे सिग्निफिकेंट अदर ने हमसे ब्रेकअप कर लिया, राइट? उस टाइम पे बहुत मोटिवेशन होती है, और सामने जब दिखता है कि यार तो एग्जाम 2 महीने बाद है, तो फीलिंग बहुत होता है। तब डिसिप्लिन भी आएगा, कंसिस्टेंसी भी आएगी, प्रोडक्टिविटी भी आएगी, सब कुछ एकदम सही रहेगा, बहुत अच्छे से पढ़ेगा। बट अनफॉर्चुनेटली और फॉर्चुनेटली दीस थिंग्स डोंट हैपन थ्रू आउट द ईयर। जैसे इस टाइम पे आपको बहुत एक लाल फील हो रहा होगा कि यार ठीक है कर लेंगे, अभी तो में टाइम है, अभी स्टार्ट करूँ नहीं करूँ, ठीक है दिन में 2-3 घंटे पढ़ाई हो गई। बट ट्रस्ट मी, टाइम तो बराबर ही है। अगर आप प्रीलिम से 1 महीना पहले पूरा सिलेबस रिवाइज कर सकते हो, तो आज भी दिन में तो 24 आवर्स ही है, राइट? द फैक्टर इज दिस एक्सटर्नल फियर एंड मोटिवेशन, और इसी को हमें टारगेट करना है। देखो मोटिवेशन एंड फियर आर टेम्पररी थिंग्स, हमें यहाँ पर पढ़ाई करनी है फ्रॉम द पॉइंट ऑफ व्यू ऑफ डिसिप्लिन। मैंने कई बार ये कहा है कि हमें यूपीएससी प्रिपरेशन को एक जॉब की तरह ट्रीट करना चाहिए। आप अपने पेरेंट्स को देखो, आपके पेरेंट्स जॉब पे जाते होंगे, क्या करते हैं? रोज 8 से 9 घंटे दे पुट इन एट देयर वर्क। दे आर नॉट इक्वली प्रोडक्टिव ऑन ईच डे, बट दे आर वर्किंग एवरी सिंगल डे। दे गेट अप इन द मॉर्निंग, दे हैव अ फिक्स शेड्यूल। ये फिक्स शेड्यूल अगर हम बनाएंगे एंड वी ट्रीट आवर प्रिपरेशन लाइक अ जॉब, इट विल हैव ग्रेट डिविडेंड्स फॉर अस इन द फ्यूचर, राइट? जब हमारे पास मोटिवेशन नहीं है, फियर नहीं है, तब प्रोक्रेस्टिनेशन है, डिस्ट्रैक्शन
1 minute भाई.
है